Plutonium-239, a metal that resides at the intersection of innovation and annihilation, embodies a paradox that has haunted humanity since its discovery. Its toxicity is legendary, with a half-life of 24,100 years that ensures its presence long after its initial creation. This isotope, a product of nuclear fission, serves as both a powerful energy source and a harbinger of destruction, a duality that reflects our greatest hopes and deepest fears. The allure of plutonium-239 lies in its potential to generate vast amounts of energy. When harnessed within the confines of a nuclear reactor, it can provide electricity to millions, a beacon of progress in a world increasingly reliant on sustainable energy sources. Yet, this same element, when mismanaged or weaponized, can unleash catastrophic power. Just a few kilograms of plutonium-239 can yield explosions that rival the bomb dropped on Nagasaki, a reminder of the destructive capabilities that lie within our grasp. The alpha radiation emitted by plutonium-239 is particularly insidious, capable of inflicting irreversible damage on human DNA. Inhalation or ingestion of even the tiniest particles can lead to aggressive cancers and genetic mutations, sowing the seeds of suffering that may not manifest for generations. The global community recognizes the grave implications of plutonium-239, leading to stringent international monitoring of its stockpiles. The specter of nuclear proliferation looms large as nations grapple with the fine balance between energy needs and security risks. The potential for corrosion or human error in the storage of this dangerous metal raises alarms. A single lapse could lead to contamination that persists for millennia, a toxic legacy for future generations. Plutonium-239's chemistry compounds the problem, as it reacts violently with air and water, forming compounds that can easily disperse into the environment, further complicating containment efforts. Historical incidents have underscored the persistent threat posed by plutonium-239. The 1966 Palomares B-52 crash, where 4 hydrogen bombs were accidentally released, serves as a chilling reminder of the fragility of our safeguards. The subsequent cleanup efforts revealed the long-term environmental impact of plutonium contamination, a costly and exhaustive endeavor that highlighted the challenges of managing this hazardous material. Similarly, leaks from the Rocky Flats plant in Colorado exposed the dangers of plutonium production, illustrating how the drive for nuclear capabilities can lead to devastating consequences for both ecosystems and communities. The potential for plutonium-239 to be used in dirty bombs adds another layer of urgency to its oversight. Terrorists could exploit conventional explosives to aerosolize this lethal substance, creating an urban nightmare where once thriving areas become uninhabitable wastelands. The very thought of such a scenario sends shivers down the spine, a reminder of how easily the line between energy and destruction can blur. Despite its sinister reputation, public understanding of plutonium-239 is often muddled by misconceptions. The unnatural abundance of weapons-grade plutonium, a byproduct of nuclear reactors, has led to a complex narrative that intertwines scientific advancement with existential risk. While popular culture often portrays plutonium as a symbol of apocalyptic threat, the reality is far more nuanced. The true dangers of plutonium-239 lie not only in its potential for destruction, but also in the intricate web of chemistry, security, and ethics that surrounds its use. As we stand at this crossroads, grappling with the implications of plutonium-239, we must confront the reality of our own creations. It is a testament to human ingenuity and hubris, a reminder that our quest for power can lead us down perilous paths. The dual nature of plutonium-239 serves as both a warning and a challenge, urging us to tread carefully as we navigate the complexities of energy and destruction in a world that is ever more interconnected and precarious.